Hey, everybody. Thanks for joining us. Good morning, good afternoon, or good evening, depending on what part of the world you're joining from. As Heather said, my name is Ron Lowry. I'm the Eastern Area Manager for Hazard Control Technologies. In addition, I've got 38 years in the fire service. I'm currently a fire chief with a volunteer department in Pennsylvania. So the presentation for today, we're talking about some of the new hazards that both, I would say, new and existing hazards that fire departments have been dealing with and are currently dealing with, and how we can handle those new hazards. So it's kind of expanding your capabilities with the use of encapsulator technology. And, those new hazards that I'm kind of referring to, the lithium ion batteries, the expanded use of Class D metals in vehicle fires, while the hazmat, tank trucks, that type of incident might not be a new hazard. I think we can offer a much better way of handling that hazard than we're currently doing. And then, issues with the whole solar panels and energy storage in general, those type of high hazard applications. So let's go ahead and cut this for right now, just so I'm not eating up all my bandwidth. So first thing we'll do is look at the encapsulator agent and encapsulator technology, kind of explain how the agent works, what its properties are, and then we'll dive into some of those unique fire hazards that we're facing and the benefits that encapsulator technology can provide. So what is an encapsulating agent? Kind of a basic textbook definition. It's a water additive. We're actually listed under NFPA 18A. It's the basic building block of the agent is that spherical micelle. That micelle is capable of encapsulating both carbons and hydrocarbons, both polar and non-polar, in the liquid and, more importantly, in the vapor state. So we actually have the ability to encapsulate flammable gases, rendering those gases non-flammable. We do that by chemically binding onto the hydrocarbon molecule, separating it from the oxygen on a chemical molecular level. So F500 is a fluorine-free, non-corrosive, biodegradable encapsulating agent. It's UL listed for Class A and Class B fire suppression. It's been tested since 2008 for lithium-ion battery fires. So we're currently used by companies like Tesla, General Motors, Duracell, Honda, Hyundai, Mercedes, Honda, pretty much go through the EV vehicle market. I would say the vast majority of those customers are using F500 for lithium-ion battery fire protection at their facilities. The last thing, the flammable liquid spill control agent. The agent's listed on the U.S. Environmental Protection Agency National Contingency Plan as a surface washing agent, so it can be used to treat a hydrocarbon spill on the ground, render that spill non-flammable, non-explosive. So real quick animation here that's going to go over what an encapsulator agent is and what happens when it mixes with water, how that spherical micelle is actually formed.
Encapsulator Technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So this orientation of the agent, both on the surface of the droplet and those micelles within the interior of every droplet, is what gives you the benefits of an encapsulator agent. And we'll cover those more in depth,
Encapsulator
kind of one by one as we go. So when we talk about basic fire suppression mechanics, we know we need to remove one leg of the fire tetrahedron to suppress a fire. And most suppressant agents work on one leg of that fire tetrahedron. There may be some minor crossover. If you're using water to suppress a fire, we're mainly working on that heat leg. But through the creation of steam, you do displace a little bit of oxygen, but it's not really all that much. So we have some minor interaction, but for the most part, with most fire suppressant agents, we're working on one leg of the tetrahedron. With F500, we achieve rapid and permanent heat reduction from temperatures over 1,000 degrees to 100 degrees or under in a matter of seconds. So we're removing the heat. We have encapsulation of that fuel inside that spherical micelle, separating the fuel from the oxygen. We're just doing it on a chemical molecular level. So we're separated from the oxygen by actually being able to remove the fuel by making it non-flammable. And then the last thing, you'll see some testing that we've had done by Clemson University, and also some other testing that we just recently received that shows we're interrupting that free radical chain reaction of the tetrahedron, which really provides a lot of benefits when we're talking from a firefighter safety point of view that we'll get into as we get through the presentation. So as opposed to most other suppressant agents that are working on one leg of the tetrahedron, with F500, we're attacking every leg simultaneously. So get into each of those unique features. So that one is that rapid cooling. How that happens is that that skin of F500 on the outside of the water droplet works like a heat sink, rapidly absorbs the heat and transfers that heat energy to the micelles within the water droplet, so we can achieve much greater cooling than plain water alone. Really good video here to drive home that point. Let me move this here real quick. Maybe. There we go. Great video to drive home this point. So the firefighter here, this is thermal imaging of a vehicle fire. So you'll see here in a second, the firefighters actually, they get the vehicle ignited. Now the firefighter in this video is going to be using a 20-gallon per minute self-adducting nozzle. As you see here, as soon as he starts attacking the fire, you have rapid knockdown and rapid cooling. When you can see the heat that's being dissipated out of that metal, how rapidly it's doing it with very little water, very little solution. So this is at a 1% concentration of F500. Again, he's using a 20-gallon per minute flow nozzle. So as you see, almost instant cooling, rapid suppression of the fire, rapid cooling of the metal, much more so than you're going to get with plain water. Next unique feature is that encapsulation of the fuels. We test that encapsulation through this NFPA 18A Section 7.7 spherical micelle stability test. So what that test entails is we take 1 part F500 to 8 parts fuel and 40 parts water, mix that all together. Then after a minute, you need to be able to pass a torch across the entire surface without having ignition. Then after 2 hours, you need to be able to pass a torch across the surface with, again, not having ignition. So what that test protocol was, we take a gallon of gasoline, add in 16 ounces of F500, and then mix in 5 gallons of water into that solution. Wait a minute, again, pass the torch over the surface, not have any ignition. And then again, after 2 hours, we need to be able to do that same protocol, that same test without having ignition of those fuels. What we're showing is that we have a stable spherical micelle in the presence of high heat for an extended period of time. That next unique feature, as I was saying, that toxin reduction, that's happening because of both the molecular weight and the cooling capability of the F500 actually helps interrupt vapor phase combustion. So some of the initial testing that was done at Clemson University, where they were burning toluene. They did several burns where they injected a plain water mist treating the smoke column. Then they matched that with the second series of burns where they were injecting a 3% solution of F500 into the smoke column. They were looking for things like light transmittance through the smoke. So what was the density or the opacity of the smoke? They were drawing smoke samples throughout the testing to see what was in the actual smoke. So what was the toxicity, what was included in that smoke. And then, the last thing they looked for was how much soot accumulated on that inverted funnel. So how much soot was actually created from the burning fuel. When they compared those results, they found that with F500, there was a 68% increase in visibility, a 97% reduction in soot, and a 98.6% reduction in soot toxicity. So again, very positive results from a safety factor for firefighters. From that Clemson study, this information, along with vapor reduction experiments, suggest an interruption of vapor phase combustion, possibly by inhibiting the radical coalescence into soot particles. So just what we were talking about earlier, stopping that soot and smoke from forming. Recently, we were just shared a study by the Laval Fire Department from Canada. So the Laval Fire Department's the third largest department in the province of Quebec. They did a multi-month, I believe it was a 6-month study on F500. As part of that testing, they did the burns here in an acquired structure where they did comparative burns using water and then F500. They did a total of 3 burns, looking at if F500 was actually giving them a better suppression, better extinguishment, but more importantly, what was it doing to lowering the toxins that their members were exposed to? So from that report, this is one of the findings from the report, that the committee to put this together is confident that the encapsulating agent reduces firefighters' exposure to carcinogenic contaminants. Furthermore, its use is also effective for class B, C, and D fires, while water should not be used on those categories. Their conclusion is, for these reasons, Laval is moving forward with instituting encapsulating agent to prevent cancer in the Laval firefighters. For this testing, they actually took hoods that were worn by the firefighters, brand new hoods, at every fire they did. They pulled the hoods and bagged those hoods and sent them off to the University of Ottawa for testing. In every case, the hoods that were worn when F500 was used compared to when the plain water was used came back with less contaminants, less toxins in that material than the hoods that were worn when plain water was used. So it gave them some pretty good indication, along with what they visually could see with their eyes, how much rapidly the fire was knocked down, how the smoke decreased, how the heat decreased. So what they could feel and see was kind of backed up by the testing that was done in Ottawa at Ottawa University. That interruption of vapor phase combustion, when we kind of go over that, most firefighters that I talk with when we're doing a face-to-face, I can see their eyes kind of glaze over. Great video here that I think kind of illustrates what we're talking about, interruption of vapor phase combustion. We have 5 burning tires, which we all know gives off that heavy black soot-laden smoke. You're going to see here we're using a 1% solution of F500. Again, very low flow here, that 20 gallon per minute nozzle. Just watch the smoke. The tires are still burning, but we're not generating that heavy black toxic smoke. That's the interruption of vapor phase combustion. We can stop that soot and those toxins from forming in the smoke. We can literally scrub that IDLH and remove, I won't say all, but a majority of those toxins, or at least drastically reduce the toxins that we're being exposed to. So now that we've kind of gone over what an encapsulator agent is and kind of the benefits, what it's doing to that fire tetrahedron, let's look at some of these various classes of fires and how it can give us the benefits. So when we look at Class A fires, we're talking about your basic structure fires, vehicle fires, dumpster fires, stuff involving scrap or recycling facilities like tires and metals, and then deep-seated fires, be that silos, or for some of the rural areas with bundled hay, straw, cotton, those type of deep-seated type fires. So another video here, again, this one, not the thermal, but the actual video of another vehicle fire. Same way, we're going to be using that 20 gallon per minute nozzle, 1% solution of F500. So we'll just speed it up here a little bit. Again, things to watch for: that heavy black smoke. Watch how rapidly that smoke dissipates, how rapidly that fire is suppressed with 1% F500 and a 20 gallon per minute flow. Notice the firefighter's not flooding the vehicle full of solution. He's just attacking where he sees fire, suppressing the fire. Now, again, he'll start to open the vehicle up, look for any spots like on the floorboards there that are still burning. Just going to hit that quickly. So on a highway type incident, we're lessening the amount of water we need. We're drastically improving visibility, which we know is a major concern with these crazies that continue to drive by us at 60 and 70 mile an hour when we're out there working a vehicle accident or a vehicle fire on the interstate. Great safety benefit of improving that visibility, getting that fire knocked down quicker, getting us off that interstate and out of harm's way faster. So this is some testing that was done up in Maumee, Ohio, just outside of Cleveland. We were actually doing burns in their burn building using F500 at a half.
All right, so let's open it up and check this out.
With both a smoothbore nozzle and then later in the evening with a combination nozzle.
1,200 at the base of the fire, 1,000 at the ceiling.
1,000 at the ceiling. Okay, so that.
At the base, 250 at the ceiling.
So we went from 1,000 degrees at the ceiling to 250 degrees. We went from 1,200 at the base of the fire to 400. So now again, we're doing the same thing in the evening. The only difference here,
You got good thermal layering right there too.
do a combination nozzle.
You got good thermal layering inside the window.
932.
What's your temperature?
932.
932.
Yep, 932.
You guys are at about 1,000, so you want to go? You want to hit and run?
See, that lower stuff doesn't look like it's burning.
Yeah. That's stuff that from this morning.
Go down on that lower stuff.
300.
That's probably just coming from the straw.
Yeah.
That lower stuff's not burning.
About 230 at the bottom and 930 at the top.
That's it. I got 975 and I was inside.
932 at the top and about 300 at the
You're not
bottom.
going to get that bottom thing burned right now.
$113. Yep.
How hot was that? What's your temperature in the hallway, guys? Hot. Hot. What's the temperature in the hallway right now?
77.
77, that's it?
Yep.
120 in the hallway.
120. You got 120 in there in the hallway? I'm getting 95 at the ceiling. 195 at the ceiling. Went from about 930 degrees to about
So again, from 1,000 degrees to standing in it.
120 in about 20 seconds
Wow.
of that.
I'm sorry.
Went from about 9.
So again, that rapid cooling. Videos here from a tire fire at a tire processing plant down in Panama. As you see that heavy black smoke. This is before they got F500 on scene. This is what the fire department responded into. Again, that heavy black smoke, just like we saw earlier. Demo fire. Now this is after they were on scene with the F500 again. You can see the tires are still burning, but as they're applying F500, it stops that heavy black toxic smoke from forming. So again, that great reduction in the toxins that are being off-gassed in that smoke, rapidly suppressing the fire, cooling that rubber, keeping the toxins down. There you can see at the end of it, you know, just finishing some mop up, getting everything cooled completely. So the chief that ran this incident actually came back afterwards because they've had fires there in the past compared to what they've done previously to extinguish these fires at this facility using plain water, and then what they were able to achieve with F500. So as a comparison, the last fire they were at, He estimated they were on scene for 40 plus hours to extinguish the fire. They used 2 apparatus and approximately 60,000 gallons of water to achieve that extinguishment. This time they were on scene for about 2 hours. They only used 1 engine and about 3,000 gallons of 1% solution to completely extinguish that fire. So again, less man hours, less runoff, less water needed, less wear and tear on the apparatus, you know, everything, just achieving a greater knockdown and greater cooling capability. Wildfire applications, these are exploding around the world. This is actually some television
Hazard Control Technologies presents
fires from a
F500
few years back down in the
technology.
Amazon where they used F500. Unless we've got folks with us from South America that understand Spanish, we're going to have to read the subtitles because all of this video footage is all in Spanish.
De martes se llevó adelante el primer operativo con el agente encapsulador en San Fermín. Es decir, con la aplicación de este agente químico se logró controlar el incendio en esta comunidad.
En este sector que ustedes han visto, sí. ¿No? Ahorita ya no hay focos de calor, se ha liquidado bien.
El agente encapsulador ha pasado la primera prueba. En la entrada hacia la comunidad de San Fermín se ha logrado controlar este incendio, lo cual ha causado satisfacción en los bomberos y también en el personal de la gobernación, que han visto la rapidez con la que se actúa y luego se liquida todo el incendio.
El primer foco de calor que apagamos con esta agente encapsulador, como vemos hasta se siente otro olor, no el olor normal. Lo tocamos, fíjense, la zona, tocamos y ya está prácticamente fría. Tenemos al medio de donde se ha aperturado el fuego una cisterna con 10.000 litros de este producto.
Se nota que tiene una efectividad elevada, ha bajado mucho la temperatura. El trabajo ha sido corto, el nuestro de liquidación. Pero dentro del proceso de extinción está la extinción, la liquidación y el control. Vamos a permanecer en el área unas cuantas horas para el control y evitar que esto reinicie. Lo más desgastante es usar una mochila, ir, volver, porque son distancias largas. Son 4 veces menos que vamos a hacer este trabajo y lógicamente vamos a maximizar la fuerza de trabajo de la persona adentro y por ende también vamos a ayudar a que esto no se reinicie. Vamos a dotar a las mochilas para poder acceder, monte adentro y lo que nos encontremos en el camino o en las propiedades lo vamos a usar con el vehículo de intervención.
Y la aplicación de este agente encapsulador es supervisado por un bombero argentino que es representante de la empresa proveedora.
See here, they're actually pre-mixing the F500 right into their tanker.
Correcta. Es un producto que enfría entre 3 a 5 veces más rápido que el agua. Encapsula mejor el humo, ustedes lo van a sentir que el olor es diferente, como si fuera un olor de un detergente. Vemos el tema de que va a ayudar con respecto a lo que es la intoxicación tanto de los bomberos como de los habitantes locales. No tiene flúor, muy bueno, queda en la tierra un par de días para evitar que se vuelva a prender. La idea de esta primera parte es mojar todo lo que se pueda. Todo lo que vos venís atacando, lo liquidás, no es que lo dejes herido al incendio, que te vas a otro lado y eso se vuelve a reiniciar mañana, pasado eso. Trabajo coordinado, termino, liquido, avanzo al próximo. Cuando empieza el fuego intenso, se ataca con una unidad un poquito más grande. Cuando se baja la intensidad, se entra el resto de las personas para poder liquidarlo finalmente. Esto ya está liquidado, está en los últimos momentos. Lo que ustedes van a ver que está humeando está dentro del área quemada, que no tiene riesgo de propagación.
So the benefits that F500 is providing in that environment, as they were saying, the rapid cooling, the reduction in smoke, the putting the fire out completely. So by achieving that cooling, they don't have to go back for rekindles because it snuffs the fire out completely. It isn't that they worked an area, they move on and then have to backtrack back because the fire started back up behind them. So we saw some video there of the agent can also be used through planes and air attacks. Again, rapid suppression, rapid Class B fire applications, be those 2-dimensional or 3-dimensional. Things like gasoline, ethanol, diesels, oils. This particular fire here is E85 gasoline. We're going to be using a 125 gallon per minute nozzle, a 3% solution of F500 on this fire. One of the things I want you to take notice of is we don't have any special application technique like you would have on a 2-dimensional fire like this with foam. So if this was foam, we would be raining it on because we couldn't roll it or bank it onto this fire. As you'll see, I'll be coming in with a dispersed pattern. We're rapidly sweeping across the surface of the fire. What we're trying to do is encapsulate the gases so that fuel is vaporizing, and it's those flammable vapors that are actually burning. We're going to be encapsulating those vapors, removing that fuel source while we're cooling the steel, taking that auto ignition, taking that ignition source away from the fuel. Fire's out. All I'm doing now is continuing to cool the steel. Rapidly cool the steel, pull the heat out, take the auto ignition temperature away. Fire's rapidly suppressed. You'll see here in a second, I'll walk back up with the chief. I'll be able to take my glove off and put my bare hand on that steel tank that was just, probably 800 to 900 degrees temperature exposed to those flames for as long as it was. Again, cooling the fuel, cooling the surrounding material, taking the heat out, removes that threat of an auto ignition. So that was E85. Here we have diesel fuel, so both polar and non-polar. We would be able to use that roll-on technique, but you're going to see the same application. A dispersed pattern sweeping over the fire. Again, we're not trying to form and roll a blanket onto the fire. We're using the encapsulator. We're using those F500, those droplets, the EA droplets to encapsulate that fuel vapor. So we're encapsulating the vapors that are coming off. Again, you'll see rapid fire knockdown, suppressing those vapors. Now just cooling the surrounding materials, taking the heat out of all those obstacles that were in the tank that even if we were trying to form a blanket would be obstructing a good blanket formation with all those obstacles in the tank. Again, rapid suppression, rapid cooling of the fire. Now let's look at some 3-dimensional applications. We get a lot of questions of, what is that 3-dimensional fire? So what we're talking about is burning fuel that'll spill or cascade from a higher plane to a lower altitude is considered that 3-dimensional fire. So things like tanker trucks, a wellhead, distillation columns. And when we look at the NFPA 11 foam standard and we look at the annex, we see right in there, foam is not suitable for a 3-dimensional flowing fuel fire or for gas fires. So though fuel was the product, foam is the product that the fire department goes to 99% of the time when fuels are involved in fire, depending on the application, it's not a suitable product to extinguish that fire. Just like you have here, this is a training fire in China on a distillation column.
Hazard control technology.
So this is going to be flowing gasoline out of that distillation column. And you'll see the rapid suppression with an encapsulating agent on that 3-dimensional flowing, spraying fuel fire.
Distillation column fire. The F500 quickly extinguishes the flames by encapsulating the hydrocarbon molecules and cooling the fuel and metal.
Cooling the steel, encapsulating the fuel, extinguish the fire. Not too many of us that I know of have distillation systems in our first due district, but sure quite a few of us have tank trucks come through on a daily basis. So this comes to from our distributor over in Vietnam. They actually constructed a tank truck simulator that is flowing diesel and gasoline down the side of the tank. So an ideal three-dimensional fire, just like we saw in the picture in the beginning of the presentation where the side of the tank melted open, all of those contents would have spilled out and been running down on the ground. So what we have here is that three-dimensional flowing fuel fire. So the firefighter that we're looking at here on the front is going to be using a very fine mist rotating fog nozzle. The firefighter on the back of the tank is going to be using a standard combination nozzle, both with 1.5-inch hand lines. So again, a pretty well-involved tank truck fire that I think most of the times here in the US, we would be hitting it with a large caliber stream from a distance. As you're going to see here, they're going to be using 2.5-inch or 1.75-inch hand lines and achieve really rapid suppression of this fire. What we found is the smaller droplet we can get, the more cooling and the more encapsulation that happens. That's why that rotating fog nozzle seems to be really effective on this type of application. So again, this is a 3% solution F500. Two streams, one from the rear of the tank, one here from this initial. They're just attacking both sides of the tank simultaneously. As you can see, that heavy black smoke almost instantly is gone again. We're suppressing, eliminating those toxic vapors that are coming off of the burning fuel, interrupting that vapor phase combustion. Again, as you see, rapid fire suppression, cooling of the fire, encapsulating of the fuels. Fire's out. All they're doing now is continuing to cool that steel. Again, we're trying to remove that auto ignition temperature, get everything cooled down to eliminate that source of ignition for the fuel that's still running down the side of the tank while they're encapsulating that fuel that's coming off of the tank. Now we get into the Class D fires, those flammable combustible metals, things like magnesiums that we're finding in vehicles and in tools. Titanium, again, found in vehicles, tools, even some of the sporting equipment now with titanium drivers on golf clubs, that types of things. And then zirconium. There are actually some zirconium, titanium, and zirconium magnesium alloys that are being used in vehicle fires. Is when we do it wrong, it can be very dangerous. So this was a fire involving titanium in Los Angeles. So as you see, they're using plain water on this titanium fire, which is a no-no. So they've already had a couple explosions around the facility. That's why they're starting to try and pull everybody back now. They're going to try and go defensive. As you're going to see here in a second, they're going to have another major catastrophic explosion.
We'll get 46s on that. Benji, get a line.
We've got other containers of titanium taking off right now.
Hey, Dozer, you want us to take it around from the other side, around the... Let's get out! Everybody out! God damn it!
So again, that's what can happen when we do it wrong on these types of fires. So this is some test burns I did with a metal recycler down in Ohio. So this is a mixture of and zirconium turnings. We have a 3% solution of F500 in the fire extinguisher. Again, a very fine mist. We want to rain it down onto that Class D metal. Again, we're rapidly cooling, pulling the heat out. Cooling that fire, not just coating it like we do with most Class D extinguishers. Here, we're actually removing the heat. We're cooling that fire and actually putting the fire out, not just smothering it with a powder and then allowing it to sit there covered until that material naturally cools. This is a magnesium fire, so this is actually a magnesium lawnmower deck, one of the old lawn boys. Here they're going to be using a hand line, again, with a 3% solution of F500. So you get that definite bright white light that you know you have magnesium involved. Again, you're seeing the same thing, that rain down technique. We're trying to gently rain the agent down, start to pull the heat out of that magnesium. Once you see that bright white start to go to more of an orangish glow, you'll see he's able to tighten the stream up, do a little more of a direct attack onto the magnesium, finish cooling it the rest of the way, put that fire out to the point that he'll be able to pick that mower deck up with his bare hand. That metal will be that cool that quickly. So now we're 42 seconds from when he started applications. He's taking his glove off, bringing the mower deck up for the other firefighters that were there to see. So again, that cooled that quickly without the explosions that you would normally see if we tried to use water on that type of fire. Again, that new hazard, these lithium-ion batteries, as I said, we have testing going back to 2008. And, you know, it's not just the EV fires that we need to be concerned with. It's the e-bikes, the e-scooters, the energy storage systems, the cell phones, the laptops. Fires that can happen not just by the battery, but can become during the course of a fire. So this is an EV powered forklift that is just, the battery's going to fail when it goes into thermal runaway. So again, in a factory setting, the most common extinguisher in the world is an ABC extinguisher. That's what they're going to try and use here in this instance. They're going to discharge multiple dry chemical extinguishers on this to no avail. You cannot effectively suppress a lithium-ion battery fire with a dry chemical extinguisher. You can't remove the heat, and removing the heat and cooling that battery is the only way to truly suppress that battery fire. So you see the first guys attacking from the right. Here comes the other employees in from the left with additional extinguishers. You're going to see even a few more are going to come running in now with even more extinguishers. So I think we're up to 5 or 6 extinguishers now discharging on this forklift. They look like they're making some pretty good progress, but all they're really doing is extinguishing some of the Class A materials that are burning. You get another battery pack goes into thermal runaway. Again, another fireball. Everybody runs off. And unfortunately, the forklift continues to roll through the facility, spreading the fire and causing additional damage. This is some testing that HCT, our European subsidiary, performed in conjunction with a company in Europe called Norapine, which is a extinguisher manufacturer owned by Johnson Controls. So this is multiple days of testing that was done for Tesla over in Europe, where they were comparing dry chemical and foam extinguishers that Johnson Control manufactures and produces in the F500 extinguisher on a lithium-ion battery fire. So you see here identical batteries that they take into thermal runaway through overheating. The same results we've seen previously with the dry powder. It just continues to burn through the powder. Again, foam is ineffective. And that fine mist from the F500 extinguisher, again, rapidly suppressing that fire, cooling the battery, stopping that thermal propagation from cell to cell within the battery. So the results of that testing, published not only by Kiowa, which is the testing laboratory that did the testing, but by Johnson Controls, where they are recommending F500 as the solution for lithium-ion battery fires. As you can see, powdered extinguishers do not apply. Foam is not recommended, but the F500 extinguisher can be recommended to apply on a lithium-ion battery fire. One of the downfalls of that particular testing that was done over at Kiowa, as you saw, the gentleman wasn't wearing respiratory protection, and he had to spend a few days in a hospital due to hydrogen fluoride poisoning from the levels of hydrogen fluoride gas that were coming off of those batteries when they burn. So they moved some additional testing over into Germany. They're actually doing this now at a technical university in Germany, both the Fraunhofer Institute and TU Klostau, two different technical colleges over in Germany. And they're doing all of the testing now remotely. So they actually have a burn lab set up where they can do both the initiation of the fire and the suppression of the fire in a controlled environment. They can monitor the heat through the use of these thermocouples, and they're also doing gas sampling through this entire event to see the gases that are actually coming off of the various style batteries that they were burning. This particular video is again of 18650 batteries, but they also did prismatic pouch and polymer pouch style batteries during this testing. So from the time they initiate the test, takes about 7 minutes for that battery to go into thermal runaway. So you see now we're about 4 minutes in, you have some venting coming off of the batteries where they're starting to off gas slightly. Temperatures building up on the thermocouples, and now we have thermal runaway. So that thermal propagation from cell to cell continues to happen. The fire continues to spread, and the heat continues to build up within the battery itself. So you see from the thermocouples now, as we'll see, the temperatures continue to rise. we're getting some pretty dramatic spikes. We're now up to 600, 700C, 500C. Just watch the temperatures on that temperature gauge as the agent starts to discharge on the battery. We were over 670C. We're now down to 19C and below. So that single application on the battery rapidly suppressed the fire, cooled all the surrounding cells, stopped that thermal propagation from cell to cell. And as they continue to let that battery sit there, it just continues to cool. The off-gassing starts. So with that one application, the battery sits there. Again, no reignition. As you can see, completely stopped the thermal propagation, that not even the plastic didn't even completely melt on the surface of the battery that was holding the cells in place. What they also found through that testing was when they looked at the hydrogen fluoride gas emissions, the batteries that were burning without being extinguished were giving off between 227 and 2,600 parts per million of hydrogen fluoride gas. When the F500 was used to extinguish those batteries, those levels dropped to anywhere from 37.5 to 1.25 parts per million. So again, a drastic reduction in those toxic off gases, just like we saw with the Clemson study. This video here, I just threw this in today. This is from some testing we did just a few weeks back with the New York, New Jersey Port Authority. Again, this is another lithium-ion battery. So this is a 48-cell 18650 battery pack from an electric bike. A torch to heat that battery up to get it to go into thermal runaway. Then they'll be using an F500 fire extinguisher for extinguishment. They're doing this burn in a cage because those batteries, when they get ejected from that pack, can travel 35 to 40 feet from the base of the pack. So they're trying to control the ejection of those batteries. That's why they're burning in the cage. So the firefighters turning the propane off now to get that heat source out of there. So it's just that battery is sustaining that fire within itself now, propagating from cell to cell. You'll see he's going to come in now with that extinguisher. So just like we saw with the other testing, rapid extinguishment. You'll even be able to hear here in a second. They're checking that with a thermal imaging camera, and that battery's down to about 91 degrees.
Oh, burn it.
So this is actually some photos from the E-Moto circuit over in Europe, where they're racing electric motorcycles. Again, they've standardized on F500 at that track for fires. This is one of the e-bikes that actually caught on fire in the charging station, where they're using the F500 to suppress that battery fire on the vehicle. Last thing we'll look at here is some hazmat incidents. Things like derailments, tanker accidents, tanker rollovers, chemical spills, and fuel spills. So these are some photos of a train derailment down in Chile. This was in a mining community. The train was actually carrying sulfuric acid. So they had not only the diesel that's leaking from the locomotive, but this is sulfuric acid that spilled from one of the tank cars. From testing that the hazmat teams have been doing down in Chile, what they found is that the F500 with a 3% solution is actually neutralizing the sulfuric acid without an exothermic reaction. So here they're actually able to neutralize the sulfuric acid, encapsulate the diesel, and remove both hazards from that accident site. This is in Argentina. This was a tanker that overturned, again, carrying sulfuric acid. They're treating that spill here the same way, neutralizing the acid without that exothermic reaction. I'm sorry, this was leaking diesel. The next one's another acid spill. So this was the diesel that spilled out of the tanker that they're encapsulating the diesel fuel. This is that other tanker accident down in Chile. Tank truck rear-ended another truck. Again, it was an acid leak, sulfuric acid. Here, firefighters, they've actually diked the acid spill to keep it from going any further. The first hazmat team that was on scene was attempting to bury it, but they were still getting a vapor cloud coming up through the dirt even as they were attempting to bury it. So the hazmat team that was carrying F500 came in. They're now treating that sulfuric acid spill, again, neutralizing it without that vapor cloud or that exothermic reaction. This last section of slides here, this was from a tanker, a gasoline tanker that rolled over an embankment off the highway in Globe, Arizona. Here they had to actually tip the tank truck to spill the contents, the fuel out of the truck, raise it back up onto the interstate. Sorry, just trying to lower the sound here. So you'll see here they're spilling the fuel out of the tank truck while they're using a 3% solution of F500 to actually encapsulate that fuel and knock the vapors down. This whole time, they had set up some remote sensors at the bottom of the hill to measure for LEL. Through the application of F500, they kept those LELs down so that they could operate safely through the entire extrication of this truck to get it back up onto the highway. So they're actually lifting the truck back to the highway now. Again, continuing to spray a solution of F500 onto the tank and the surrounding areas, just keeping those vapors down to make sure they didn't have an explosion from the flammable vapors that could have come off the tank. So I think the really sweet spot with F500 is you have one product that can handle multiple applications. It helps take the guesswork out of what we need to use. A water, a Class A foam, a Class B foam, an ARA FFF, an AFFF, a Class D extinguisher. You have one agent that can save you both costs on buying multiple products, plus one agent that works across multiple classes of fires. And thank everybody for your time. I hope it was informative. Again, if you think of any questions after the fact, don't hesitate to reach out to us. If you don't have a good contact email, you can always email info@hct-world.com. And Esther Griffin, our wonderful inside sales customer service, will get you routed to the correct person to get your question answered. Again, thank you for your time. Stay safe out there, and hopefully we'll see you all in the next webinar.